Hello everyone. In this video, we're going to write complex numbers in polar form. Recall, x equals to r cosine theta, y equals to r sine theta, and x squared plus y squared equals to r squared. The complex number z equals x plus yi. We can substitute x and y by r cosine theta and r sine theta. Therefore, we have z equals to r cosine theta plus r sine theta I. Factor out the r. We have z equals to r times open parentheses of cosine theta plus I sine theta. This is the polar form of the complex number, where r is the modulus and theta is the argument of the complex number. Often, we also use r cis theta to represent r times open parentheses cosine theta plus I sine theta. Write in polar form. Example number 1. -2 plus 2 square root of 3i. Please feel free to pause the video so that you can give this problem a try. Very nice. Recall that z equals to x plus yi. Since we know x equals to r cosine theta and y equals to r sine theta, if we now factor out r, we will have the polar form of the complex number that z equals to r times parentheses of cosine theta plus I sine theta. We can first find the r, the modulus of the complex number. The complex number -2 plus 2 square root of 3i. We have -2 units on the real axis and 2 square root of 3 units on the imaginary axis. To find the r, we will have r squared equals to x squared plus y squared. Now as we take the square root, we will have r equals to square root of x squared plus y squared. Substitute x by -2 and y by 2 square root of 3. We have r equals square root of -2 squared plus 2 square root of 3 squared. Simplify. We have r equals to square root of 4 plus 12, which is square root of 16, which is 4. Therefore, the r equals to 4. Now to find theta, since we know that the x is -2, the y is 2 square root of 3, we recognize that this is a special triangle with the reference angle of pi over 3. Therefore, to find theta, we could have pi subtract pi over 3, which is 2 pi over 3. Substitute r equals to 4 and theta by 2 pi over 3. We will have the polar form of this complex number as z equals to 4 open parentheses cosine 2 pi over 3 plus I sine 2 pi over 3. Write in polar form. Round to the nearest tenth of a degree. Example number 2. 8 minus 3i. Please feel free to pause the video so that you can give this problem a try. Very good. Recall that the polar form of the complex number is z equals to r times parentheses of cosine theta plus I sine theta. We can first find the r. We plot the complex number that 8 units on the real axis and -3 units on the imaginary axis. To find r, we will have r equals to square root of x squared plus y squared. Substitute x by 8 and y by -3. We have r equals to square root of 8 squared plus -3 squared. Simplify. We have r equals to square root of 64 plus 9, which is square root of 73. Now, we would like to find theta. Focus into the triangle in the fourth quadrant with adjacent side 8, opposite side -3. We have angle theta as the reference angle, and we can use tangent to find alpha, that tangent alpha equals to -3/8. If we take tangent inverse to both sides of the equation, we can find alpha. Be sure you will change the mode to degree, as stated in this question, that to round to the nearest tenth of a degree. So then now alpha equals to -20.6 degrees. To find theta, we could have 360 degrees minus 20.6 degrees equals to 339.4 degrees. Substitute r by square root of 73 and theta by 339.4 degrees. We have the polar form of this complex number as z equals to square root of 73 times parentheses of cosine of 339.4 degrees plus I sine of 339.4 degrees. Thank you for watching my video.